Happy Thursday. We are here for math and we are going to have so much fun with math today. We're going to do some major first grade problem solving. And in order to do that, I'm going to teach you two new math words. They are probably words you have heard before, but maybe you've never thought about using them in math. These words are true and false. Now, you guys have heard the words true and false before, right? When a statement is true, it means it's correct. Like, George Washington was the first president of the United States. That statement would be true. False is an incorrect statement or a wrong statement. Like, Miss Egan was the first president of the United States. That is not true. Miss Egan was not the first president. I'm not even president now. That statement is false. Now, guess what? We can use these words in math also. When an addition sentence, an addition equation, or a subtraction equation is completed, it can be true or it can be false. So let's do an easy one. And I'm just going to remind you, remember that equal sign? This is what helps us know if a math equation is true or if it's false. This equal sign, so important, tells us that this side of the equation is equal or the same as this side of the equation, right? So let's try. 1 plus 1, let's use my counters here. 1 and 1 equals 2. I'm going to show I have 2 counters here. Is that equal to 2 counters here? It absolutely is. Let's try, what if I do it this way? 3 is equal to 1 plus 1. I have 3 counters here. I have 1 plus 1. Is this side of the equation equal to this side of the equation? No, it's not. This addition equation is false. It is not true, right? I can make it true. 2 plus 1 gives me 1, 2, 3 is the same as saying 1, 2, 3. Does it matter that I have this part, this part here and this part there? Not really. We are used to reading it the other way. But if you remember, right, that equal sign is just a number sign, right? If you remember these signs, like 3 is greater than 1, it's just a sign to split that number sentence apart in order for us to read it with a symbol. Okay, so just remember that that equal sign is a symbol showing us that one side is equal to the other side. And we're going to use that today to see if sentence math equations are true or if they are false. So if you don't have them, pause Miss Egan and go get your 10 frames and your counters, because I know this was a little easy to do, mental math in your brain, but we're going to do bigger number sentences, right? All the way up to 20. So we might need some help in order to figure out if they are true or false. Okay? So let's find out if they are true or if they are false. At the top of the page in your book on page 363, 3-digit number, right? Are the equations true or false? 14 minus 4 equals 10. Now, I know you might be able to use mental math to do this, but let's just work it out. I know you can use mental math because you know that this 4 has the same value as this 4, which only leaves us with this number, right? Which is the value of this number. But let's try. Let's just make sure. Work through it. So I have a full 10 frame and I have 4 more, which gives me 14. I'm going to take away this part. 1, 2, 3, 4, which leaves me with this part. Is that number sentence correct? Is it true? It is. This number sentence is true. Ding, ding, ding. Let's see the other number sentence they gave us. 11 plus 6 equals 16. So our first math equation was subtraction. This one is addition. So what we're doing differently here is we're starting with a part, adding another part to see if it gives us the whole. So I'm going to have 11 reds, and I'm going to put 6 yellows so I can see my two parts to see if it gives me 16, right? So let's count. 1, 2, 3, 4, 5, 6. 11 reds plus 6 yellows. Does it give me 16? No, it does not. It gives me 17. Is this addition equation true or false? It is false. Absolutely. This one is false. Why is knowing if number sentences are true or false good? Well, when we solve our own problems and we write out the answer, we, like Miss Egan always has us go back and I write our related addition fact in order, or use our counters to check, right? Well, could we write a false statement by accident? Absolutely. So that's why it's always good to get used to seeing them. They could be true. They could be false. We don't know. We have to go and check. So how could we write this true? 11 red plus 6 yellow. The correct answer is 17. That answer is true. Ding, ding, ding. Okay. Now, in your books on this same page, we're going to solve problems numbers 1 through 6. So have your 10 frames ready. They don't have pictures there. Now, what we're going to do is we're going to read the addition or subtraction equation. If it is true, you're going to circle the equation. If it is false, we are going to give it a big X because it is not true. Okay? Let's see what our first equation is. 9 equals 18 minus 9. So is 9 equal to or the same as 18 minus 9? Let's figure that out. This sounds vaguely familiar to me because I know my doubles facts, but I'm going to check with my 10 frames and counters. So let's start. Our subtraction sentence is 18 minus 9. So I need 18 red counters. What do I have here? I have 10, 11, 12, 13, 14, 15, 16, 17, 18. And I'm going to take away my known part. I know this sentence, right? 18 minus 9. What I want to figure out is if it is equal to 9. Okay? So let's do 18 minus 9. I'm going to flip over 9 reds and make them yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 18 was my whole. I started with 18. I'm flipping over 9. That's my known part to see if my missing part is 9. Is this number sentence correct? It is! Ding, ding, ding. That number sentence is true. Give it a circle. I'm going to put a little check mark here so to know that we have gotten one true so far. Awesome work. Awesome work. And remember, that equal sign is just showing us that this side is equal to this side, right? I know we're used to reading it the other way, but Miss Egan will never trick you guys. Okay, number 2. 12 plus 7 equals 19. So we just did a subtraction equation. Now we're doing an addition equation. So we want to start with 12 reds. I'm going to make 12, right? I have a full 10 frame and 2 more. That's my part. I'm going to add another part to see if this is the same as that, to see if this is equal to that. 12 plus 7. I'm going to have 7 yellows. 1, 2, 3, 4, 5, 6, 7. Are 12 reds and 7 yellows, 12 plus 7, equal to 19? Yeah, we got another true statement. This time a true addition statement. Super work, guys. Let's move on to number 3. That one was easy peasy for us. Okay. Number 3. Okay, they have that number sentence a little backwards again, but don't be surprised. 16 is equal to 10 minus 6. Well, before we even start, 10 minus 6. If this is if it's a subtraction sentence and this is supposed to be my whole. Remember, our whole is always the biggest number. And here's my subtraction sentence, right? Here's my subtraction equation. This is telling me, right, a subtraction equation, that should be the missing part, which means this is the whole. Take away one part gives me the other part. Could a part be bigger than the whole? No. So right off the bat, I can tell this equation is not going to be true. But I want to work it out and find out why. So we want 10. 10 is our whole. We're starting with 10. Ready? Take away the counters in your second 10 frame. 10. Ready? 10. Take away 6. I'm going to flip over 6 reds and make them yellow. 1, 2, 3, 4, 5, 6. 10 minus 6 is what? 4. Is that number 4? Not even close. So guess what? This equation is false. It is not true. Not even close. Not even close. It should say 4 is equal to 10 minus 6, right? We see right here 10 minus 6 is 4, and that would be the same as 4 on this side, right? Absolutely. This side is now equal to this side. This equation is true. This equation is false. Ooh, they tried to trick us, but you are too smart. Okay, let's go to number 4. 15 minus 9 equals 6. Okay. Is this side of the equation true to this side of the equation? In order to figure that out, I have to solve 15 minus 9. Well, here's my whole. I'm going to take away a part. So, in your 10 frames, let me see 15. I'm going to do 15 reds. All right, I got one full 10 frame, and I have 5 more in my other 10 frame. 15 minus 9. Okay, now in order to figure this out, I'm going to flip over 9 and make them yellow so I can see my missing part. See if this is the accurate, if this is the true missing part. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is 15 minus 9 equal to 6? Yes, this subtraction equation is true. Ding, ding, ding. It is true. It is true. I like getting those true number sentences. Those false ones are too crazy. Let's try number 5. All right, number 5. 8 is equal to 6 plus 3. So is this side of the equation equal to or the same as this side of the equation? Well, we have an addition equation to solve. So we're going to do part plus part and see if this is the whole. Okay? So I'm going to start with 6, right? 6 plus 3. Let me add 3 more. is 6 plus 3 equal to 8? Do I see 8 there? No, what do you see? 6 plus 3 is equal to 9. So this equation is false. This equation is not true. If we wanted to make it true, we could say 9 is equal to 6 plus 3, right? But this equation is not true, so give it a big X in your book, right? That equation is not true. No way, no way, no way. Okay, number 6. 13 minus 6 equals 7. So, is this side of the equation, our subtraction equation, equal to or the same as this side of the equation? Let's find out. I'm starting with my whole, taking away a part to see if this is the accurate missing part, if this is the true missing part. So we want to start with 13 counters. 10, 11, 12, 13. And I'm going to flip over or take away 6. That's taking away one part to see if this is the missing part. 1, 2, 3, 4, 5, 6. Is 13 take away 6 or 13 minus 6 equal to 7? It is. This statement is true. This number sentence is true, true, true. Woo! First graders, you are rocking this true and false. It's so exciting to do something new and try something new. And you're doing awesome. Let's turn the page. We got a few more, 6 more that are just like this. We're going to circle them if they're true. We're going to give them a big X if they are not true. Okay, ready? 5 is equal to 10 minus 2. Do you know that one right off the top of your head in your brain? Is that true or false? It must be false because I know my doubles facts and I know 10 minus 2 does not equal 5. But let's find the correct. Okay, this is my number sentence, right? 10 minus 2. And I have to figure out if that is equal to 5. Well, here's my 10. And I'm going to take away 2. Is 10 minus 2 5? 10 minus 2 is equal to 8. This equation is false. Give that a big ol' X. The more you get used to doing these, you'll be able to know right away, well, that is true, that is false, and you know why? Because your number sense is so strong. Right? That is not an accurate fact family. That is not true. Not true at all. Okay. Number 8. 9 plus 4 equals 13. This is another one I can solve in my head. I know the answer, right? My number sense is really strong. I know my 9 addition facts. But let's solve it. So, my addition facts, right? Part plus part equals whole. Let's see if this part of the equation is equal to this part of the equation and if it is true or not. So there's 9 and I'm going to add 4 more. 1, 2, 3, 4. Is 9 plus 4 equal to 13? I got a full 10 frame and 3 more. Yes, that is true. Give that a circle. 9 plus 4 is equal to 13, right? Because I know in my brain that addition facts with 9 are just 1 less than it would be with 10, right? If it was 10 plus 4, it would be 14, but it's 1 less, so it's 13 because 9 is just 1 less than 10. So now that you're getting used to these true and false statements, it's becoming a little quicker, right? Because you can look at this right away and say, yep, that's a fact family I know. I am used to seeing those numbers together. That is accurate. That is true. All right, what number are we on, boys? Number 9. 13 minus 2 equals 11. Here's another one that I bet you can solve right away, no delay. 13, my whole, take away one part, equals the other part. Is this statement true or is this statement false? Let's work it out. 13, take away 2, equals 11. This statement is true. Ding, ding, ding. Because I know right away, if I can, 13 minus 2 equals 11, that is true if 11 plus 2 equals 13. And it does, right? We see that here. 11 reds and 2 yellows equals 13. Those related facts help us out so much. It's all clicking together. All right, number 10. 15 plus 3 equals 18. So we have an addition equation. Is this addition equation true? 15 plus 3. Does that equal 18? I know you know, but let's show it. So my one part is 15. My other part is 3. Does that equal 18? It does. Ding, ding, ding. We got another true. And you guys are so smart. I bet you are rocking this. You're doing amazing, amazing, amazing. All right, let's look at number 11. We have 8 equals 14 minus 2. Let me look at this real quick. 14 minus 2. What would that be equal to? 14, take away 2. See if you can do that in your brain. Is that equal to 8? Let's find out. I'm going to make my 10 frames have my whole, which my whole is 14. So I have a full 10 frame and 4 more. And I'm going to flip over. I'm going to make them yellow, this part, to see if it gives me this part. To see if this statement is true or if this statement is false. So take away 2. Is that answer 8? No, that answer is 12. Is 8 equal to 12? Is 8 the same as 12? No. So this number sentence, this subtraction equation is false, 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 false. Give it an X. That number sentence is not true. We can't get past you guys, right? You are too smart. You figure this out. Okay, number 12. 16 minus 6 equals 10. I know you know this one already. I know you're chomping at the bit. I think I can hear you screaming. Oh my gosh, I know. I know you got the hang of this now, guys. But let's show it anyway. Is this part of the equation equal to, the same as this part of the equation? Here's my subtraction sentence. I'm going to start with my whole, 16, and take away 6. Here's 16. I got a full 10 frame and 6 more. And I'm going to show this part that I know. 2, 3, 4, 5, 6. Is 10 my other part? It is, which makes this statement true. Let me hear you scream it. It's true. It is true. You got it. You got it. Oh, brush off your shoulders. That was a lot of hard work. You did amazing. Okay, before I'm going to ask you to do this all by yourself, let's do our problem solving together. Now this time we're going to have to read the problem, plan the problem, write the problem, and figure out if the problem is true or not. Right? This is when this true and false really helps us out. It helps us see and make sure that we read and wrote the problem correctly. Lisa has 16 flowers. I think 16 is going to be important. I'm going to write it down. She has 7 pink flowers. The rest are yellow. Write a true equation and solve. So she starts with 16. She has 7 that are pink. How many are yellow? Write a true equation and solve. So if 16 is all of the flowers she has, and this is one part of the flowers she has, we have to figure out what the other part is. So this type of sentence is going to be addition or subtraction? Subtraction. So here's my subtraction equation. But I have to solve it before it's true, right? 16 minus 7 doesn't equal question mark. I have to solve it. So let's solve it. I already have 16 here, right? I have a full 10 frame. I have 5, 6 more. That gives me 16. All right, I'm going to wait. I want you to set up your 10 frames also so that we can solve together. So 16, I'm going to take away, or I'm going to show my 7 so that I see what my missing part is. Ready? 1, 2, 3, 4, 5, 6, 7. So, what is the answer that will make this equation true? What is the answer that will make this equation true? 9. 16 minus 7 equals 9. That subtraction equation is true. Ding, ding, ding. That is true. Super, super work, guys. Okay, I want you to solve the 6 problems on page 365 all by yourself. If they are true, you're going to circle them. If they are false, you're going to give them a X. Talk to you later, guys. Bye.